Hi, my name is Gautami. I work at Latent AI as a machine learning engineer, and my day-to-day involves building and deploying AI models for edge devices. The security of our work, especially models, is a top priority for us, as some models may be trained on sensitive information that's highly important for our customers. Edge models are susceptible to a range of cybersecurity attacks. For example, there's always a risk of input manipulation tasks that are designed to alter a model's performance, parameters, and behavior. Some attacks involve retrieving private information from the model that it was trained on. Other attacks involve the theft of the model. So, to increase the security of AI models, we use a specific technique called watermarking. Watermarking involves embedding a signature inside the model so that we can prove the ownership and potentially detect unauthorized use of the model. Watermarking AI models is extremely difficult because it involves modifying the model's internal structure, like its weights, its behavior, without affecting its main functionality. This involves complex algorithms and a good understanding of the model to ensure that the watermark survives common changes such as pruning or compression. Additionally, the technique must work across a variety of models, so it needs to be really generalized. But at Latent AI, we have developed this super cool tool called LEIP Optimize. LEIP Optimize can do a range of stuff, but one of my most favorite things about what it can do is that I can use it to add watermark to any model of any size and which is built for any device easily in just a couple of code lines.
What I have here is a Jupyter notebook, and in this I'm going to show how we can load an IR representation of the model using Forge or LEIP Optimize and then add a watermark. I'm just going to go ahead and import all these libraries, and for the model that we are using to add our watermark, we have just selected a general model from Ultralytics, which is a YOLO V8 small. Let's load it using Forge, and let's just see what the intermediate representation looks like of the model. So here I can see that there are around 331 nodes for my model, and these nodes are basically all the operations that are done within the models. We want to surgically try to change this and add a secret message within the model. So how do we do that? Now let's just type out something. Here I have an example which says confidential model encrypted by Latent AI, and let's just go ahead and do Forge add watermark. Now that I've gone ahead and added my watermark, let's try to do inference on using our model. Before we do inference, I want to just see what the outputs of my model look like. Here I have the original model, and I also have the model with the watermark. So if you take a look at it at a glance, you can see that nothing much has changed. You can see just a few numbers, like 95 has changed to 94 in the model with the watermark. That's because we have manipulated the least significant bits. So now we are going to go ahead and see if both of the arrays are equal or not. So you can see that it's not, so that something's definitely changed. But does that mean that it's going to affect our confidence score too? Here's the inference for the model without a watermark, and here's the inference for the model with the watermark. So it's detected the airplane, and the confidence score hasn't changed even a bit. It's still 89%. Let's do this for another image. Again, it's detected two airplanes, and the confidence scores of both of them have not changed at all. So that's how easy it was to add a watermark using LEIP Optimize. Give it a try today.